Hello viewers, now we are going to say about design of muff coupling. So muff coupling can be called as sleeve coupling or box coupling. So generally it is a type of rigid coupling which consists of two parts, one is sleeve, another one is key. So which is fitted over the end of the input and output of the shaft by means of the sunk key. So key is provided to hold the shaft and the sleeve. That is the purpose of key here, and it is a simplest form. Why? Because it has only two parts, one is sleeve and the key, and another you can say as shaft also, right? Only three poles are here. And this is a schematic diagram of muff coupling. So it has only three poles, as I told earlier. One is muff coupling, another one is key, another one is shaft. So here diameter of shaft is noted as D in lowercase, and diameter of sleeve is given as D in uppercase, and length of the sleeve L is noted here, right? So this is the some of the parameter we have to consider here, right? And this is the design procedure for muff coupling. So generally it has four steps. First one is design for shaft. We have to calculate the shaft shaft diameter here. So for that, formula is mt equal to pi by 16 into tau s into d cube, right? So to find out the twisting moment, or can call as torque, right? Mt, or we can call as torque. Mt is nothing but twisting moment, or we can call as torque. So for that, formula is P into 16 into 1000 divided by 2 pi n Newton per mm. That is unit for torque. And second step is dimensions of muff coupling. So here we have to find out two things. One is outer diameter of the sleeve, capital D, you have to find out. For that, formula is 2D plus 13, right? And second thing, length of the sleeve. Length of the sleeve L equal to 3.5 into T. So these two things we have to calculate in the second step. And third step, design for sleeve. Sleeve design we have to undergo here. So that is formula for formula for sleeve design is mt equal to pi by 16 into tau into d power 4 minus d power 4 divided by d. Why? Because sleeve in the form of hollow, right? So we have to go for outer diameter and inner diameter. Outer diameter can noted as capital D in uppercase, and lower diameter, inner diameter is mentioned as D in lowercase. So formula is mt equal to pi by 16 into tau into d power 4 minus d power 4 divided by d. So this is the formula for sleeve. And last one is design for key. So here we have to consider two things. One is shear failure and another one is crushing failure. So for shear failure, formula is mt equal to L into B into tau. Tau is nothing but, we already know that tau is nothing but it's a shear stress, right? L into B into tau into D divided by 2. And for crushing failure, mt equal to sigma c. Sigma c is nothing but crushing stress. Sigma c into L into h divided by 2 into d by 2. So this is the fourth step we have to follow for designing the muff coupling. Yeah. So this is the example for problem for muff coupling, right? Just read out the question. Design and make a neat dimensional sketch of a muff coupling which is used to connect two steel shafts transmitting 40 kilowatt at 350 rpm, right? Power value is given as 40 kilowatt, right? And speed is given as 350 rpm. And second thing, the material for the shaft and key is plain carbon steel, right? The material which is made up of for the shaft is steel, for which allowable shear and crushing stress may be taken as 40 megapascal and 80 megapascal respectively. So that means shear stress we have to take as 40 megapascal. So when you convert that megapascal into Newton per mm square, the same value, right? 40 megapascal, that is equal to 40 Newton per mm square. And for crushing stress, sigma cs, right? For crushing stress, sigma c is equal to 80 megapascal. So we can say as 80 Newton per mm square. And last thing, the material for the muff is cast iron, right? Muff is made up of cast iron, for which the allowable shear stress may be assumed as 50 megapascal. So that is tau c equal to 15 megapascal. So we can say as 15 Newton per mm square, right? So now we'll solve the problem. First thing, we have to design the shaft, right? Design the shaft. So in this step we have to, the first thing, we have to find out the diameter of the shaft. So after finding the diameter of the shaft only, we can able to go for design for sleeve and design for key and all. So first thing, we know that formula for finding the diameter of the shaft is twisting moment, or we can say as torque equal to pi by 16 into tau into d cube. So to before going to that formula, we need to know the torque value, right? Torque. So for that formula is tau, mt or t equal to p into 60 divided by 2 pi n. So we'll get the answer in terms of Newton meter. So once you convert that Newton meter to Newton millimeter into 1000, so finally we'll get the torque value, right? So after finding the torque value, just substitute in the formula, right? So that is 1100 into 10 to the power of 3 equal to pi by 60 into tau s into d cube. There tau s value is given in the question itself. Just substitute that value, that is 40 here. After that, just solve the equation and you will get the diameter of the shaft. So diameter of the shaft is 52, we can say as 55 mm. So 55 mm the is the diameter shaft for the particular question, right? Clear? And second step, design for sleeve, right? Design for sleeve. So before that, we need to find out the two things, dimensions of sleeve. Two things. One is outer diameter of the shaft and another one is length of the muff, length of the sleeve. Formula is capital D equal to 2D plus 13. Diameter value is known, which we already found in the previous step. So just substitute that value and we will get the diameter value 125 mm. And second thing, length of the sleeve. Length of the sleeve, capital L equal to 3.5 D. Just substitute the D value and we will get the length 195 mm. Right? So after that, just substitute in the design for sleeve formula. That is T equal to pi by 16 into tau C into D power 4 minus D power 4 divided by T. Right? So in that, T value, torque value is known value. Right? Torque value is known value. Capital D is known value and small d is also known value. That thing, the unknown is tau C. Right? Tau C we have to calculate here. Right? So after finding that 2.97 Newton per m square, that is the torque for sleeve. After finding that, you have to compare, which is given in the question, right? Given in the question as 15 Newton per m square. So what we founded value compared to the given value will be small, right? 2.97, which will be less than the 15 Newton per m square. So the design is safe. Second step is over. In last step, design for key, right? Key design we have to calculate here, right? So for diameter, for soft diameter, that is 55 mm, will take the width value and thickness. Width value will be 18 mm and for thickness also 18 mm. Right? So and the length of the case, half of the capital sleeve value, sleeve length value, so it will be 97.5 mm, around 100 mm. Just substitute all those value in the shearing failure formula. Shearing failure formula is nothing but torque equal to L into W into tau into D divided by 2. Right? In the torque value is known value. Length which we calculated in the previous, that is L equal to L by 2, that is 97.5, that we will substitute here, and W value is taken as 18 and tau we have to find out here, and diameter is known value, right? So finally we will calculate the tau, that is 22.8 Newton per m square. That is the shearing failure, right? So after that, the last thing is we have to calculate the crushing failure, right? Crushing failure, that is formula is torque equal to L into T divided by 2 into sigma C into D divided by 2. So in that, T value, remember torque value is already we calculated in the first step itself, right? That is value was 1100 into 10 to the power of 3 equal to L into T divided by 2 into sigma Cs into T divided by 2. So here L value is already known value 97.5 and thickness also known value 18, and sigma C we have to calculate here, right? What do we have to calculate here? Sigma C, right? Crushing stress we have to calculate here. So final value of crushing stress is 45.6 Newton per m square. So which will be less than the given value. So given value is 18 Newton per m square. Here 45.6 Newton per mm square. So which is less than the given value. So then design is safe. So that's it for the design for muff coupling. Thank you.